Ready to roll?
Can't stop the signal.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 278. We'll be talking about DIY subs, the ErgoRing, and finding NEMA 17. This week in the news, we just finished up the business card challenge. We got 80-something entries. They are all super fantastic. Keep your eyes out on Hackaday for the results there. And that means this is the last weekend to get your call for participation in for Hackaday Supercon. Supercon goes on in November in Pasadena, California. Is absolutely fantastic. I guess we could fit 512 people into the space, so that's what we got. Tickets have not yet gone on sale, of course, but if you want to secure one, get a talk in. 20 minutes or 40-minute talks, both of them get free ticket, free attendance, guaranteed. I'll throw the link in the show notes where you can find the forms to fill out for the call for participation. Get your talk and or workshop ideas in now, and we'll see you in November.
Can't wait.
It still seems super far away.
It does, but it is hurtling towards us.
But it's runaway train. Speaking of hurtling toward us, here comes What's That Sound?
I like that. That's a pretty good segue.
This is a journey into sound.
What's that sound?
What's that sound?
This week is a Let's See Who Won week. So that means, Tom, you get to listen, see if you can figure it out, and then I'll tell you right away whether you got it or not.
That's good. At least I don't have to stress over it for too long. Let me play it here. Oh, okay. So that's got to be like a CRT degaussing.
Damn. Right? Absolutely correct.
It was that first one. I almost was gonna say like a Jacob's ladder or something. I heard some kind of a high voltage thing, but then the subsequent ones reminded me of my youth.
Man, congratulations! That's awesome. Yeah, I don't think I would have gotten this one, frankly. If
really?
I hadn't picked it. I think not. I don't know.
I guess maybe it speaks to my future interests, but I spent a lot of time in my youth like pressing the little degauss button on the monitor. I was fascinated by that, the noise and the thing it did. So I trained my whole life for this moment.
That's fantastic. Yeah, a bunch of people got it right. Funnily enough, your wrong guess of a Jacob's ladder was actually picked up in there too.
That was my first instinct. Was like, oh yeah, Jacob's ladder, because something about that noise. So maybe they got so excited they sent their answer in before they heard the other ones.
Yeah, so super. Congratulations, and congratulations to 17. Wow. I don't know. Am I being too picky? Actually, I'll ask you real quick here.
Okay. Did they have to have the model of the degausser or something?
Yeah, no, but a lot of people said CRT monitor powering on.
Oh.
Are there monitors that do automatic degaussing every time they turn on?
I would say that's certainly possible.
Yeah. A lot of people, about half of them said degaussing and the other half said turning on. And I don't know how...
Yeah, I mean, I can kind of...
Let's see what we see out of that.
That's kind of like the quintessential, like, turn the TV on noise, like a dong. It does make a similar sound.
Yeah. Most of the newer monitors automatically degauss whenever they are turned on.
Yeah, okay.
Yeah, it says Dell in 19... When was this? This is not...
I waited this to be a 9 or an 8, or what's the next number?
Why does it say 2023? What?
Wow, okay.
Some have a control to manually degauss, others automatically degauss. Oh, yeah, all right. I'm going to have to go back and recount this one then and take the CRT's turning on answer as correct. This is going to take me a sec.
I mean, I will say the first Reddit response, and of course Reddit is the indisputable source of all human knowledge.
Absolutely.
But the first one for CRT turn on sound, somebody says, "What is that noise?" And they say it's the degausser coming on.
Okay,
that
fine.
makes that that classic noise. And that's
Fine.
because somebody in the year 2 ago,
Yeah.
they just got their first CRT and they're like, "What is this weird noise it makes when I turn it on?" And everybody said, "No, it's fine. It's fine. That's what it does."
All right, then that's it. I'm revising my estimation of the number of correct answers. We now have 24 correct answers, counting everyone who said old monitor, CRT monitor turning on. Congratulations to all the degaussers and all the monitor turn-oners. Today I learned. You know, now that I think about it, I must have heard that sound more than I've pressed the degauss button. All right, well, that gives us 24 possible answers. Oh, I came up with a totally new random number generator this time. And that is, the classic way to get a random number generator is you have a slow clock and a fast clock, and the slow clock has some jitter relative to the fast one. And so, you wait 10 seconds and then you look at how many ticks have elapsed on the faster one. And if there's enough jitter, the last couple digits there will be random. And then I'm like, wait a minute, I've got a timer in my computer that tells me what the time is down to the millisecond. I'm just going to use that. So I'm taking the Unix time date plus %S, capital N, and doing that modulo how many number of contestants we got. And I have no idea what time it is right now. So this is as good as anything else. And we got, 24 people? So here goes. 1, 2, 3. 12. Congratulations to number 12. Congratulations to Jones Boy. CRT monitor turning on and the degaussing coil kicking in. Oof.
Wow, come on, that was...
Congratulations.
I mean, if you're looking for a succinct answer, I think that even answered the debate we had. Right? Like, we should have just read the response.
Should have just read the winning answer after I knew it was going to be the... Wait a minute. Well, congratulations, Jones Boy. I'll get in touch with you and get a Hackaday t-shirt out to you. Everyone else, stick around. Next week, we'll have a new sound for you to listen to and guess. So let's head on off to the hacks. I wanted to start off with Auntie Swanto's long write-up of an amazing story, solving cold cases with hack-together gear. And this is the story of Auntie and his brother building an ROV to solve some old missing persons cases in the Finnish woods. I mean, first of all, Tom, you wrote this piece up for us, and you said in an incredibly engrossing series of blog posts. And I remember after I read this, when I was editing this one, I read the blog post, and I'm like, wow, that is the craziest story I have heard in months. Tom had better have written this up right. And that's so I went back to your post, and I'm like, yeah, that's the correct link. Incredibly engrossing is the truth here.
What's it, like 12 parts or something like that? He goes so much into the background and why he wanted to do this and try to solve missing person cases. I mean, it is just really a phenomenal read all around. And
so it makes a horrible choice for the podcast because I'm not going to sit here and read this guy's website to you.
Right.
But I am going to tell you that if you've got the time, you should absolutely go check it out. The basic story is that they had a couple missing persons cases local to them. They built 2 boats. One was a pontoon-based kind of remote-controlled rover that had a side scan sonar on it so they could image the bottom of the riverbeds where they ended up looking for the cars that these people probably went missing in. And the other was a deep diving rover, and it's just an absolute beauty. It's got, custom made light mounts and a dry hull and a wet hull, and it's got RC motor thrusters and, the whole thing. It's a real serious piece of kit. Their basic procedure, and what I thought was really interesting about this, was that they would go out with the side scan sonar, look for traces of the car or whatever on the bottom, and then go try to drive the rover down to image the thing to see what they could see, right? But as an intermediate step, they put a big magnet on a rope and went kind of trawling because what they were looking for was car wrecks, and they figured they could, attach the rope to it. And that also gave them something visually to kind of follow down as they went down into the riverbed with the rover. And that's, of course, tremendously useful because if you watch one of these videos of theirs, they're just piloting this thing through dark and murky all the way until they get within probably 2 feet, 3 feet of the car at the bottom. And so having this rope that's already attached to the thing they're aiming at was super helpful. And in the second attempt, actually, they put some retroreflective tape on it that shows up in the video feed as well, so they can see every meter or whatever, how far they're going down. And it gives you something for scale, too, because just kind of following a line into darkness, you really lose all sense of orientation and everything. So really cool kind of operational details there. But again, the star of the show is some really neat, simple hacker ROVs, and also just incredible persistence and thinking, if I were driving off the road, where would I be? Where would this person go, and where would I end up? And just, thinking that through as if you were the missing person got them a long way. I mean, they went looking in the right place when they found the stuff.
Like I said, when you read the blog, some of them have no technical details at all. It's really just them, reasoning through it, and like you said, trying to figure out where would they be and how would they have gone missing and what was the background story. Which is not a knock by any means. I mean, I think it really added a lot to it. You're reading through, and it'll be like, okay, here's two, 3 posts in a row about making the ROV. And then it'll switch over to this kind of narrative, and I mean, it was just awesome. I'm waiting for the the Netflix docu-series about about these two. It really is an awesome story. What a fantastic thing to use your skills on. Try to bring closure, to some of these. I think the cases that they found. I mean, we're talking like a decade. These people have been missing. And the families had no answers. And I actually watched some of these guys on YouTube that do these sort of recoveries, and they always say, like, we hope we don't find anybody, right? Because you don't want to have to give that bad news. But if you do, then at least there's an answer. And even a bad answer is better than no answer, right? So the tech is really cool, too. I did really appreciate all the details about how they built the ROVs. It's interesting because the pontoon one is, it's clearly like the lower tech of the two of them. And it struck me as, this was sort of like, forgive the pun, but like the first toe dip in the water, right? Like they built that to see, like, okay, well, what can we actually see? What's going to be, is this a waste of time? Are we going to be able to see anything on the bottom? So it was kind of put together, I would say, in a, certainly not sloppily, but expedient, let's say. It was PVC pipes and some like angle iron, and I thought one of the interesting things is, they have the side scan sonar module, which is just like an off-the-shelf commercial thing made for fishermen or whatever. And it had no way of, well, I guess no easy way of getting the information off of it. So they just parked an old smartphone in front of it, looking at the screen, and then did like a video call to the phone, right? So then they're on the shore with another phone, seeing effectively just a video of the screen. And he mentions in the write-up that it was kind of terrible to navigate with because you had that delay, but they recorded it, right? So at least they had the high-res recording of the screen to go back to. And it is a little funny that it all started, that part all started because they didn't have a boat, and they didn't have any room for a boat. But by the end of the story, they get a boat. Because once you've gone down this rabbit hole, eventually you need to, gear up. In the end, they do have a boat, and the sonar thing was maybe less necessary than they thought, but it's still really cool to read about how it was built. And then that led into the deep diving ROV, which is just phenomenal. I mean, that's a real beauty and very capable. They went all in on that one.
It's funny you mentioned the pontoon boat, and then they just ended up buying a boat. When I watched what they were doing with the rover, I'm thinking, they could do this much simpler too, because they're already throwing a line on the end of a magnet down to the wreck. All they need is something that can fall down this line with a camera on it. Like, you could use a piece of lead weight and a camera and a light, and you just send it down the rope and see what you hit, And, maybe give it a little more maneuverability. In the second find, they did try to maneuver all around the car to see if they could see the license plate number on it, which would be super useful information. But then they got lost. They got far enough away from the line that they couldn't see it again, and they got lost in the dark and had to float back up and give that one a pass. It makes me think you could make some kind of a line-guided robot that would go do it. That'd be neat. But there's tons of interesting detail here. Like, this is a hobbyist ROV sub along the lines of a bunch of others we've seen here. And I love this tech. And they, of course, link out to it, which is really neat too. Like, to build the tether, they get a rope and then they run waterproof Cat 5 through it, right? And so you thread that through the thing. And then you have a rope that's strong and then can carry your electrical signals down. They mention the SV Seeker design for some of the thrusters and, just drawing on a whole bunch of kind of post 2000 hacker submarine designs to make this thing work. And I think that's really cool also, that it's all open designs and everybody working on similar things that let them spin this up as easily as they did. And they say as much too, of course.
Yeah, that was really cool. That, like that, for each detail they had somebody's name, and a link back, and we all kind of, obviously we know that happens, right? We know it's like this note comparison happens, but it is kind of rare to see somebody go to such detail to say, hey, this is exactly who I got this idea from. So it was really cool. I mean, honestly, the whole thing is just kind of like a high watermark for me in like hardware hacking activities and documentation and pretty much everything.
And some real good coming out of it at the end of the day too, right?
It's tough to top this one, no matter which way you look at it. Well, my first pick this week was kind of big doings in the 3D printing community. I wouldn't be surprised if some of the listeners already had heard about this situation. Titled Long-Term OctoPrint Stat Manipulation Uncovered. What happened was, at this point, I think it was only a few days ago, right? It was earlier in the week. Looking at the stats for OctoPrint, and there's a public website, data.octoprint.org, and you can see all kinds of stuff, utilization, how many installs, and it's just an interesting metric, right? To see how many people are out there running it, what the growth is like. And lead developer Gina was looking at the stats and said, well, that seems weird that there's an unusually high number of old OctoPrints out there, right? Anyone who's used OctoPrint, it automatically updates itself. So there shouldn't be so many outdated ones out there. It's a very, very easy update process, right? So she starts looking a little bit deeper into it and wondering why are you seeing, tens of thousands of outdated installs? She hasn't gone into a whole lot of the technical details. She said she kind of wanted to keep the way she found it, a little bit of a secret, so in case this happens again. But she was able to figure out, basically, it was bogus data. It looked like real installs of OctoPrint, but it was obviously the product of some kind of script. Somebody had figured out what the telemetry package looked like and was just mimicking it and shooting it out to the stat server and screwing up all the numbers. The next question is why? And it turns out that one of the things that the telemetry reports on is what plugins you have installed. So while it was clever enough that, each install that was being reported had this peppering of popular plugins, the vast majority of them had one plugin in particular that they all shared, and the end result is that plugin, Octo Everywhere, gets rocketed up the list of most popular plugins. And at the time that she found this, it was at number 1 popularity list. So, everything's kind of piecing together, and we have sort of a prime suspect right here. If one plugin has been shot to the top of the list from, manipulation of the information, who's the next call you make, right? Send out an email to them. They say, oh, this is crazy. We don't know nothing about this. And in a very short time later, they come out with a statement that says, well, it was somebody in the community and we told them to stop it and everything's fine now. And, we're very sorry. And everything goes back to normal. And we're going to make sure from here on out that no more manipulation is done. I gotta say, it's not a very convincing story to me personally. I did write this one up, and I said it in the write-up. Just the fact that they were able to find this person within such a short amount of time kind of doesn't bode well, right? Like, he must have not have been hidden to you if it wasn't that hard to find them.
Well, how many devs do you think there were for that? I mean, they probably just wrote everybody an email and said, hey, somebody doing this? And they're like, yeah, maybe.
Well, well, even that they call it a determined community member. So I took that as a user, right? Like somebody who used the plugin and really liked it and wanted it to seem like it was the more popular. I don't know. I mean,
I don't know either.
it's hard to right. We don't know. And they said we handled it internally. We're not going to say who it was, which is also very convenient, right? I told my mom that when I would break something, I'm like, mom, I broke the lamp, but we handled it internally, and we're not going to talk about what happened. So it's over now. Please continue.
We've investigated the issue, and
we've investigated ourselves and found us guilty of no wrongdoing. So anyway, that's kind of neither here nor there. The end of the story is that the bogus data has now been pulled out. The stats are returned to normal. Interestingly enough, the plugin in question didn't even go. I mean, it went from like number 1 to number 6, which I thought was kind of funny. It wasn't even like they were at the bottom of the list to begin with. But the kind of the big takeaway is that Gina says she posted on Mastodon and said that she felt like kind of upset that the numbers she thought she was seeing were not real, right? There's something like 40,000 in the end fake installs that she thought was organic growth. And I should say, I don't know if I mentioned it, this has been happening over the course of 2 years, right? So it wasn't like from May to June 40,000 new users popped up. This was it was a very clever attempt. I mean, credit where credit's due. Slowly over time, more and more of these fake ones were brought online, so it looked like organic growth of OctoPrint, and she was kind of feeling jazzed about that, right? I mean, that's what you do this for. It's what you hope for when you're putting out an open source project, that people are using it and digging it. And she said she felt kind of like a little deflated to find out that those numbers were not real, and that the growth she thought she was seeing wasn't real. And I just hope that once all the dust is cleared, that she remembers how important this project is, and how much people appreciate the work that goes into it. And it does suck that somebody was messing around for their own personal gain, but I think in the long term, what anybody's going to remember about OctoPrint, right? Like, the OctoPrint's an incredible project that has, I would say, changed desktop 3D printing, honestly. Certainly refined it. And, I hope this doesn't weigh too heavily on her for too long, because the good that she's done has certainly outweighed anyone playing games or just feel better. Feel better. Don't worry about these people messing with your numbers, because your growth is unquestionable anyway, right? Like, from our end, we can see just how many projects come our way that are using OctoPrint, and it's kind of like everywhere.
Yeah.
So I think everything's going to be okay in the end.
I also followed Gina's Mastodon account, and I was like really sad to see that she was so saddened by this, right? And part of me was like, well, they're just numbers. But I understand that you can say, it's so awesome to see it growing like that. But on the other hand, I think the numbers underestimates the impact it has on a lot of people too, because
oh, sure.
Like a lot of stuff in our kind of niche of the world, OctoPrint is used by people who are real 3D printer enthusiasts and for whom it makes a real difference. It's a real difference. Even if it were a real difference for 1,000 people, it would be an awesome piece of software. And this is kind of so much over that hurdle. It's easy for me to say from outside, but in my mind anyway, it's all just kind of rounding error. It's like what they always say about the first Velvet Underground record. Nobody bought it, but everybody who did formed a rock and roll band, And I think OctoPrint is a little bit like that too. The raw numbers don't really tell the story of its impact anyway. And I could totally imagine how that would feel to be like, oh, the rug has been ripped out from underneath.
Oh yeah, I mean, it definitely had to be a blow. But
yeah,
like you said, they are just numbers, and I think it's important to remember that they are opt-in anyway. So it was never really a clear picture, like you said, of how many people are using this thing. I think that the clear picture, just how you can't go anywhere, honestly, where they're talking about 3D printing and not hear about OctoPrint. Go and on any video or any Reddit thing, and someone eventually is gonna be like, "You got OctoPrint? Hey man, you got any more to OctoPrint for me?" Like it is like almost synonymous with 3D printing at this point, at least like in the enthusiast kind of community. So. Numbers are numbers. There's no question that the work is being appreciated, and is only going to get bigger with time, frankly.
That's funny. This is what you get. If you try to put up stats like this, somebody's going to try to game them. You know, it's really human nature, human nature. But.
Yeah, the one thing she did say, she kind of did use the numbers to sort of direct development time, and you know, because obviously a lot of stuff is being reported, and she's really just focusing on, in this case, plug-in shenanigans. But there's probably other stuff in there that was like, you know, what internal features are being used, and that would direct where effort should be put. So she felt like that was kind of the biggest betrayal, is that she was putting energies towards things that maybe were not actually being used. But again, I don't think anybody who uses OctoPrint would say that she's wasted even an iota of her time in developing it, right? Like it is a phenomenal piece of software that everybody started its own community. So I get it, be bummed for a little bit, but just try to, you know, keep in mind how big of the impact this thing was, and nobody's gonna remember this when they think about OctoPrint. They're gonna think about all the work it saved them and all the experiences they had with it, and it'll all work out in the end.
Next up for me is a video from engineer Bo putting some numbers on your NEMAs. And this is the video, as Dan, who wrote this up, says, has the best title ever, Finding NEMA 17. It is a stress test of a bunch of NEMA 17 motors. Along the way, it is a really neat dynamometer build and a test of motor drivers as well. And so there's a lot to learn here, both in terms of, you know, the comparison across the stepper motors. The differences are minor, and mostly, you know, this one has better low end torque by a little bit, and this one runs at the high end a little bit faster. This one has thicker wire so it can handle more current. You know, and the differences across the motors ends up being not so important. But what does end up being important, to totally just steal the punchline, is Bo tries it out with a newer stepper driver that is the TMC 2209 silent stepper motor drivers, and then an old school stepper motor driver, the TB 6600. And the difference between these is that the newer ones do all of this clever current chopping drive stuff, and they try to make the current pulses more sinusoidal and all of this. And it turns out it really matters. And especially in the kind of low speed torque case, it actually makes a huge difference. And that was kind of the biggest take home for me when I was looking at the raw numbers here, is just how much better the more modern motor drivers are, and how that difference just swamps the should I buy this motor or that motor choice. Oh, and did I mention torque curves? The real star of the show for me here is the really sweet dynamometer he makes. It's a Prony brake style one where he has actually a bike disc brake on there, and then that is on a pivot, is free to move, and then presses on a scale, on a weight cell, and he can read the torque off. You calculate the length of the arm that's pressing on the weight scale, and then that gives you your torque in feet, pounds, or Newton meters.
This is a cool one. It's almost though like where was this video 10 years ago for me, because in the dark days of 3D printing, when printers were wood and the pulleys were sandpaper, you would find people debating brands of stepper motors, and this is I can't even. It's funny. It seemed to be such a big deal at the time, but even thinking about it now, I can't even remember any of the names. But you had these people who were like diehard. I only buy these brand steppers, and I bought this 3D printer kit, and the first thing I did was I threw the steppers away and replaced them with whatever brand. And it was always like, it was such a big deal, and to see this kind of test and find that on the whole it's not nearly as much of a big deal as we probably thought, and the performance. I mean, I'm sure there is some super cheap ones out there that maybe would fall in comparison, but on the whole, the motors are stepper motors. I mean, it's not hugely important. They're kind of all the same. Like you said, the drivers are where the magic really happens, and what separates. I mean, even today, to a degree, one of the big things that would separate Prusa from like a Prusa clone is that the real Prusa is using these high end steppers with the silent drivers, and the current sensing, so you don't need end stop switches and all. All that's done in the motor drivers, which are more expensive than the cheapy ones, which work but are noisy and they need end switches. So a lot of the magic of the 3D printer is in the motor controllers, and I don't know if that's always super obvious to the someone who hasn't necessarily taken the thing apart and really figured out how it all works. I mean, you have two printers that look exactly the same, right, mechanically, and even the steppers could be the same, but under the hood, just having that different driver chip in there could be the difference between something that does okay and makes a lot of noise or something that is reliable and quiet and a workhorse.
Yeah, 100%. It's funny you're talking about the old days. I remember speccing out motors for this, right? You had to look at the holding torque numbers and make sure you got that right. And back then I had no idea about, how stepper motors worked internally, and I didn't know that there was this kind of parallel winding, series winding difference and a bunch of other stuff like that. And so on reprap.org, it says get 0.4 Newton meters. So I tried to get motors that had those specs, and that was, just blind, right? Well, a few years back now, I bought a CNC machine, and it had stepper motors that were parallel wound. So they had a ton of grunt, but then it couldn't travel fast because it was limited by those. But the thing was also on ball screws, so it didn't need so much grunt on the motors at all. So it was just like the people who built and designed this machine picked the wrong motors for it. And so I spent like $50 on eBay, swapped the servos out for the right ones, and now all of a sudden the thing will run at blindingly fast speed, and everything's groovy again. So these sort of things do matter. Actually, what's fun when I was doing the research for that, my real take home here is that series or parallel kind of gives you a feel for whether it's going to be torquey or high speed, but there's really a trade-off there. And so, you need to know what you want. And then other than that, basically all the rest of the performance of the servo motor can be summarized by how much the thing weighs. Because there's just no way to get around the physical necessity to have lots of wound up copper inside the thing to make it turn hard. And I thought that's really funny. But you can almost source your servo motors just by looking at how much they weigh and whether it's series or parallel wound. That basically is the only spec you need. Before we leave, the dyno here is so awesome. It's completely automated. The disc brake is actually thrown by yet another stepper motor. So the rig Bo sets up here can turn the motor at a whole bunch of different speeds and then tighten the caliper down on the disc brake until it stops it, and then record how much force it took to stop it at a whole bunch of different speeds. You can get an automated version of the entire torque curve, and that's just fantastic. If your needs are not so fancy, you can check out an article written by Ann Ogborn, Measure 3 Times, Design Once, where she talks about ways to make a simple prony brake, and she's got a design with a slipping strap and a weight on the end of it that doesn't give you this dynamic whole torque curve type thing, but is a heck of a lot simpler to build if you just need to kind of ballpark out a motor.
All right, well, this next one, as soon as I saw it, I knew I wanted to talk about it for the podcast. ErgoRing makes computer interactions comfortable is the title, and this is just such a cool peripheral. It's a lot of off-the-shelf components. It's got a little trackball thing, sensors, and kind of everything sort of, how do you do, wired together. I mean, the hardware is a little rough at this point, but where this really shines is Sophia, the creator, has done just a phenomenal job on the software side and, interpreting all the data coming in from all these, like the trackball, but there's sensors and there's capacitive touches. There's a lot of stuff going on there, and it kind of pulls all that together and makes for a very natural input device for the computer. And I often fool myself into thinking that the keyboard and the mouse is like the pinnacle of input technology, and that if it works for this long, it'll work forever. But in watching this video that she has, I realized, well, maybe I was wrong. Maybe there are better ways to do it, and that aren't just the gimmicky things that come down the pike once in a while. You could look at this as like an assistive tech, and it would be totally valid for that, for somebody with limited dexterity, as long as you can move your finger, basically you can move the mouse cursor, and then there's ways to type with it, by picking, letters on the on-screen thing. But, in the video, she basically says, I'm just very restless, and, sitting properly at a computer is not really her thing. So, like, in the video, it just shows her in all these, like, weird positions and, like, sitting sideways in the chair and just doing all that stuff. But no matter how she sits or where she can always control the computer, because she just has this thing on her finger that's letting her navigate and, short of plugging into your brain and reading what you want it to do directly. It did show that there's room for innovation and room for making this interaction with the computer a little less rigid and more flowing, depending on how, you like to personally do things and wherever you're comfortable. And I think it's a very, very exciting project, and I'm looking forward to see. I mean, this is like the newest of the new. I think when we put the thing out, even the YouTube video had like 10 views or something. Like it was, it's very, very new. So this is happening very, very quick, and I'm really excited to see where this goes and see the development. And you got to watch the video, because I mean, showing it in action and how many things you can do with just your thumb and your finger, whether it's rolling the ball around like a simple trackball or just doing the gyro. Like there's so much that is pulled out of. These are not expensive pieces of hardware we're talking about here. These are like the same kind of little sensor boards that we've all got in the junk box, right? It's really just how it's all being pulled together in the software. Just fantastic work, and something to keep an eye on for sure.
So I don't know if you said what this thing is at any point in time here.
It's hard to say what it is exactly, so right?
it's a ring, and it's got Bluetooth, and it's got a trackball on it, and it's got a couple buttons, and it's got a cap sensor, and I guess it's got an IMU on it, and so it's got a couple modes. You could press one button, and the trackball is just a regular trackball mouse, and you can click on it and move your mouse pointer around. The other mode, it lets you do it into a keyboard mode where you can actually use your finger to write letters, and it will type them because it senses what you've done with your hand using the accelerometer, using the IMU. That mode strikes me as the slowest possible way to type, but if you just need to make a couple corrections, right? Like the button on the trackball is enter, the other button is backspace, and so if you just need to correct a typo on a document, it's like 4 letters. Boom, you can do that real quick without having to get up and get to your keyboard. I love that. The capacitive touch sensor plus mouse movement just looks so organic. We all read a lot of stuff on the internet, and how much time do you spend like scrolling down the page? Or, if it's a PDF you're reading, you're sitting there scrolling. Why do you have to use something on your desk? Why don't you have a little ring on your hand that you can just scroll comfortably with? Like, it's such a brilliant, I agree with everything you said. It's such a brilliant application. But it's such a brilliant application made up of so many kind of simple but just right little parts. And it really is sweet. And there are a bunch of different versions of this. You should go check out her Hackaday IO page, where she actually kind of gets into how the thing is built. And of course, the code's over on GitHub. But there are kind of different iterations of this with different 3D printed cases on it in different, more or less polished. And it really does look like something that I could totally see just having on my hand right now. Boom, scrolling down the page. Oh, I'm all for it.
It's very organic. That's the takeaway. And that's the thing that's hard to describe unless you actually see the video and see how much you can do with just on your hand. It's a very natural way. But this is something that I think everybody would probably get some usage out of. Even if it's just scrolling through and clicking around, you don't have to do the traditional thing. It's just a cool reminder for me anyway that there's still stones yet to be uncovered in what seems like a solved problem.
Boy, speaking of new stones turned over in old stone piles, 3D printing ideas came up with instant filament drying satisfies an immediate need. This is an incredibly simple idea, but it seems to work very, very well. If you are in a climate where it's humid enough that your 3D printer filament absorbs water, when you go to print it out, it boils, and that puts little steam pockets in there, and you get little blobbies in your resulting extrusion. A lot of us take extra special care then to store our 3D printer filament, especially as it gets older, in kind of, I throw some desiccant in the drawer. I actually try to store most of my filament in the boxes it came in with a little extra silica in there just to, keep them from absorbing too much water. But say you've screwed up and you have some filament that's already picked up water and you need to dry it out. Well, you can put it in the oven for many, many hours at a very low temperature, or you can buy one of these fancy filament drying boxes. Or 3D printing ideas here is he connects together 3 tin cans, runs it through this 3 tin can long space with a heater and a fan on it, and basically blow dries and dehydrates the filament as it's printing out. That's the whole gimmick. There's nothing more. If you want to dry out your 3D printing filament on the fly, you can. You just make a long tube for it and you put a hairdryer on it. And my God, it works. I think just the kind of the simplicity of this solution and the fact that you don't see anything like this in the market is mind-boggling to me. The guy who runs the 3D Printing Ideas YouTube channel, 3DPI67, if that is your real name, asks himself, why don't I see this out there? And he finds like a couple projects doing something similar, but that's it. I think partly the answer is that it's not the right solution. The right solution is to keep your filament dry in the first place and then, dry it in bulk second if you need to. But this is totally the expedient solution. And this is the awesome expedient solution. And it's just too simple. It really is just you can dry out your filament on the fly as it's spooling into the printer. I think it's not energy efficient, maybe. I think you'd waste less energy if you put the whole roll in a box and ran a hairdryer on it than if you hair dried it, one section at a time. But other than that, I can't see much to not recommend this idea. Quick and easy to hack together.
I don't want it to sound like I'm turning my nose up as like some kind of filament snob or something, but like you said, just proper storage, I think would solve all these problems. Like personally, I've never run into this. I see it come up a lot. People say, "Oh, the filament's wet and it's crackling and popping." And like go on Reddit and on the 3D printing, any of the 3D printing subreddits, and you'll always find somebody complaining about this. And I've never run into it because, like you were saying, I for the most part keep them in the original bags. I bought a bunch of extra the color changing silica packets, right? So you can see when they're soaked and change them out. It's one of those things where I feel like just be kind of proactive, and you don't need to come up with this solution.
I think it's a simple, quick hack. If you want to play around with it, you can get yourself any old tube and a hairdryer, and you'd probably be testing it out within 5 minutes.
All right. Well, my last one here, when I pick the things to talk about for the podcast, I usually reserve this spot for the ones that are fascinating, but perhaps not high on my list of things I want to do from day to day in practicality. In this case, it is Google Drive now bootable, and this is, it's a very interesting hack. Essentially, it's using Fuse on Linux to make Google Drive a bootable file system. Because that's something you've wanted to do, right? Conceptually, not far off from stuff like PXE network booting, except it's the cloud, which is just somebody else's computer farther away. I appreciate the work that went into it, and it's a good example of what you could do with Fuse, which stands for something, I'm sure. File system and user space or something.
Something like that. User space file system.
Yeah, those letters didn't work out, but I think that's the general gist. Fuse is like a general Linux thing for making stuff appear to be a local file system. I know one of the things I've done with it in the past is you can mount like a remote SSH connection as a local file system, which is pretty cool. Anyway, it's a good example of what Fuse can do, and I guess there's probably some practical application for this, but it's more just, to me, just a cool proof of concept. In the comments, as so often is the case, you got people talking about, network booting and that kind of thing. And it kind of personally reminded me of how cool I continue to think network booting is. I don't get to do it as much as I like. It's always something I like to play with, just to, have like a a server on the network and be able to like boot Raspberry Pis and stuff over the net and pull the initial file system from a remote device. So like if you ever wanted to play with that, maybe if you ever wanted to experiment with what it's like to boot something over the network, but you didn't have the little home lab set up, maybe this is an option that you can look into.
Yeah, the thing I learned about this was the dra-cut shell file or whatever that makes creating an initram FS easier. And if you're not deep into the Linux boot setup, the initram FS is, it's just a file that sits there on your disk. And then it's kind of mounted and creates this fake boot time RAM file system that you can use to, make the system boot up like you want it to. And this dra-cut thing looks like a great way to take a running system and make an initram from it. So I think that's pretty sweet too. Like you say, Fuse is awesome. When we were working on the badge last year, the MicroPython on it has a file system that exposes itself, and you can use Fuse to mount the file system that's on the Pi Pico on the badge on your local drive and just work with those files as if they were on your computer. Fantastic fun. Fuse is awesome. My first quick hack this week, Les writes, lasers al fresco, fun with open cavity lasers. And if you've been following Les's YouTube channel, he likes to play with lasers. And there's a really fun one called an open cavity laser where the reflector mirror isn't inside the tube but exterior to it. And you can play around with switching these mirrors out. And he's doing that in this video. It builds a lovely 6-sided mirror switcher to swap in different mirrors and playing around with higher reflectors, less high reflectors. Deep dive into what makes a laser a laser. Next up, Morrissey's So much going on in so few components, dissecting a microwave radar module. I've looked at these RCWL0516 radar modules and wondered how the heck they can work with so few parts. This is the best explanation I've seen yet. It runs a kind of carrier at 3.18 gigahertz, and it's kind of starved, and then it starts back up, and then it's starved, and it starts back up at this 20 megahertz rate. If you're in the neighborhood, you bounce more of this carrier back at it, and that starts up the next 20 megahertz cycle faster. And so you can use this phase shift to do the radar. It's kind of, Morrissey describes it as regenerative receiver radar by wishful thinking, and I love it. It's an amazing amount of functionality for like $3 worth of parts. Last up, Wilmore, try out MCUs with this jumperable TSSOP20 adapter. If you've looked at all those little breakout boards, little dev boards for every microcontroller in the world, they've all got the same stuff on them. They've got like a USB connector, they got some buttons, an LED, they got power conditioning, and then the microcontroller in question. This is trying to make a generic board for TSSOP size ones, targeting particularly the CH32 family of chips, but anything in this footprint will work because he's got all the parts there, and then on the back, there's kind of a wire matrix. So you say, I want power on this pin, and I want GPIO on that pin, and I want USB on this pin. Wire it up yourself, solder the board on the front, and it's got all the peripherals there. It's kind of fun. It's like a dev kit, do-it-yourself build kit.
All right, well, my first quick hack is the definition of a quick hack. This is a 3D printing with a twist, and it's a video about a tool developed by Andrew Sink that lets you twist an STL. That's it. Like that's the end of the that's the end of the quick hack. Loads up a little gnome guy that kind of is the tutorial, right? And you can pick how much twisting you want to do and the range and stuff. But it's just what it sounds like. You just twist the thing around. I think you could probably do the same thing with extrude command and open SCAD that lets you like add a rotational thing. But this could be used for artistic purposes. You might have something that you want to twist up. Somebody in the comments says you could conceivably put a STL of a gear in there and twist it if you wanted to make twisty gears. I don't know. It's a cool project. It's up on the web. You can mess around with it, and hey, I'm sure somebody out there will get some use out of it. Next up is make a cheap robot mower much smarter. I love this one. This is a robot mower from the grocery store. This is too European of a concept for me to understand, but apparently you can get cheap robotic lawnmowers from the grocery store out there, and this is a very basic little bump and go kind of car / lawnmower. Gabriel wanted to integrate it into ESP home setup. The real hack here, which I love, is that the mower had a rain sensor that basically would just tell it to stop if it starts raining. And since the only functionality that Gabriel was looking for was a way to stop it and start it, just tapped right into the rain sensor. So there's an ESP A266 riding on top of this thing that just basically says, hey robot, it's raining, when it wants to shut it down. So I think it's a really cool way of, tapping into the existing electronics in a, fairly non-invasive and potentially even, undoable way, if that's your kind of thing. And finally, an open Xbox mod chip enters the scene. This is a story of the RP2040 once again showing up as a mod chip for a game console. We've seen it on the GameCube. We've seen it used as like a flash cartridge for the Game Boy. Like, there's so many game consoles that are getting modified, thanks in large part to just the sheer number of I/O pins it has on it. This time it's the Xbox, and it's got an open source firmware and lets you do mod chippy things to your console, which generally speaking is running bootleg games and emulators. But the nice thing here is that in the past, a mod chip was the kind of thing that you had to get from like some shady website that was always in danger of being shut down and stealing your money, because this is certainly towards the gray area of hardware hacking. Pi Picos and other boards with the RP2040 are everywhere and can't stop the signal, right? So this is certainly a much more sustainable and open way to modify these old consoles instead of having to, go on the darker side of the internet. So that's always a cool thing for, like video game preservation and stuff, these old machines working and usable with open source software and easily available hardware.
That brings us to the Can't Miss articles. These are fantastic pieces written by our own Hackaday writing staff. This week I'm picking Al Williams' A Brief History of Perpetual Motion. This is lovely. I love perpetual motion devices. They violate the first law of thermodynamics. They don't exist, right? But they fascinated people from Leonardo da Vinci on, and a good percentage of them are dreams. Half of them are ideas where you're just neglecting friction. And then the rest of them are just all out hoaxes. And it runs this like gamut from dreamers to actual fraudsters. And, a lot of them also embody the magic trick, right? Like, it shouldn't happen. It can't happen, but here it is happening. And so it's kind of fun to see how they work when you can. There's all sorts of fun to be had with perpetual motion machines. And this is just a great write-up. One of the things that came out in the comments was this website that I've never seen. The Museum of Unworkable Devices is an insane collection of, perpetual motion machines, fakes, frauds, and then some real ones. It's got a lovely section called Fake Perpetual Motion Machines You Can Build, which just goes down the kind of classic ways in which perpetual motion machines are made, whether it's solar power or induction or hidden batteries. I didn't even know there was a radium-powered perpetual motion machine, but apparently there was. How clever is that? It also mentions the atmospheric clocks, and I'm going to drop a link in the show notes. One of the almost perpetual motion machines on this list is the Beverly clock, which is a clock built in 1864 that uses the difference in temperature across the day to expand and contract the bellows that then runs a ratchet that then winds the clock. And it's been running almost every day. There have been a couple days where the temperature didn't swing enough in Australia and it actually stopped. But basically every day since 1864, which is pretty cool. This idea was also commercialized in the Atmos clocks made between 1929 and 1939, and 500,000 of those were made. So you actually probably could find one used. Again, same thing, uses temperature differential to wind the clock every day. That's what I think is really cool about these, is that a lot of these perpetual motion machines are fakes. some of them are interesting secret energy harvesters, and some of them are funny energy transmission mechanisms that you can use in your own projects. I mean, the people who are doing the, big coils of magnets and it extracts the energy of the ether or the 0 point energy or what is dark energy? Even astronomers don't know. But here we are with a bunch of wrapped up copper around some Coke cans and we can harness it. Like that sort of stuff, yeah, you keep it to YouTube. But I love seeing how these things work on the inside because some of these techniques I could probably use in my own projects.
I like that you mentioned keep it on YouTube because that is certainly the source of many perpetual motion and free energy devices. Like how Al kind of closes it. Like this has always been a thing. All of recorded history, somebody's been trying to make a perpetual motion machine, but now the Yahoos have an easy way to reach millions of people, and the end result is predictable. I can't tell you how many times I've seen people duped by somebody just like putting a battery across the plug of a TV or something and turning it on, and they're like, oh man, like this is the trick the energy companies don't want you to know, that a AA can run your TV, but no, it's just that they have an extension cord and you don't see that because the cord goes off screen for a second. There's always somebody looking to make the impossible possible. Well, now for clicks, I don't know what you would call it back then. Maybe just the applause, I guess, if it was back in the day. The idea of the perpetual motion machine, like this, assuming you're not a big fan of like the laws of thermodynamics, or you think of them more of it as a set of guidelines than laws. It always seems like it's just so tantalizingly out of reach, right? Like all I need is like one more magnet in the right place, and I can get this thing to spin forever. And there's a mystique to that I think kind of speaks to the hardware hacker, right? I know I've always been fascinated with these perpetual motion machines, and even though I know better, like I can't help but be fascinated by them and look at them and like I said, some of them are legitimate puzzles. Al mentions there's a video midway through the thing, Adam Savage investigates this one that's like a real head scratcher, right? And the answer to how it works was supposedly sealed in an envelope before the creator died and all that. So I think even if you know better, right? Even if you understand that there's no such thing as perpetual motion, I think that they provide an interesting puzzle for the engineering mind.
And sometimes the pursuit of these impossible perpetual motion machines can actually make some really creative engineering. And in the kind of hacker YouTube space, I'm still struck by Laser Saber's motors. And he built these super low friction electric motors that would just run forever and ever and ever. And I'll throw a link into his kind of crowning glory here in the show notes, which was a motor that was sitting on magnetic bearings running inside a bell jar, so it had very little air friction, and just with this ultra efficient motor design he has, and it's just really lovely. I think he had the motor running on microamps under normal conditions. Really astounding. Is it perpetual motion? No, of course it isn't. It's awesome engineering, but that makes it all the much sweeter.
All right, well, for my pick, I cheated a little bit. This one was technically last week, but I couldn't help but bring this one up. This is the SS United States, the most important ocean liner we may soon lose forever, by Maya Posh. This is just a fantastic write-up about the United States, the origins of the ship, and, right into its very sad current state, which is sort of a evolving situation because as perhaps you heard in the news, the slip it's moored in Philadelphia, the owners want it out. It turns out they're not super happy about this giant rusting ship being in there for the last 20 odd years. And now it's a question of where the ship is going to go and what's going to become of it. And unfortunately, there's an excellent chance it's going to get cut up and turned into paper clips. And that is a real shame. And Maya did, I think, an excellent job of explaining why that is, right? I mean, there's been plenty of ships that have turned into, I guess by the numbers, most ships end up getting scrapped, right? If you think about it. But this is a very unique ship, kind of the last of its type. It was designed by William Gibbs, who was a self-taught engineer, which really should resonate with a lot of our people. And he went on to do a lot of ships in the post-war period. The idea with these particular ships to make them almost like a hybrid kind of a ship, like the United States was on the surface a cruise liner, right? But it was designed in conjunction with the Navy to have kind of like this second life as a wartime asset, not a warship per se, but for like troop carrying. You can see how after 2 world wars, the United States government would think this is a good idea, right? To have these fast, big ships that could easily be converted into troop carriers when presumably World War III was going to break out at any day, right? Luckily, as you may have noticed, that never happened. So we never needed to convert ships like the United States over to a fast troop carrier. But the work that went into it to make that possible is very interesting. I mean, it has the power plant is basically pulled right out of a Navy battleship. It's actually similar kind of a setup to the Iowa class battleships, which I wrote about going to see the New Jersey a few weeks ago. They have kind of remarkably similar engineering spaces because, United States was built with those lessons in mind, right? Like to have redundant boilers and these powerful engines. The top speed of the United States even now is not known for sure because it was like a classified military secret. The Navy didn't want people to know how fast it could go if it needed to. If it needed to really put the hammer down and get out of there. How they wanted to keep that kind of as a surprise for the enemy if it ever came to it. And other stuff like the whole superstructure is built out of aluminum to keep it lightweight. Very famously, nothing flammable was used in building it, and that included even like the furnishings. There's one of the kind of the famous stories about the United States is that even the grand piano in the ballroom originally they had an aluminum piano that sounded like an aluminum piano, and they were like, okay, this just won't work. We need to have some kind of luxury. So that was like the only wooden thing allowed on the ship is that they replaced the aluminum piano with the mahogany one. But even then, they had to test it and like try to set it on fire and see like, okay, like how long would it take to burn? Like, is it actually going to be a liability? So so it was that serious that this thing was impervious to fire and that kind of thing that they originally didn't even want a piano in there. The ship obviously never had to enter into military service, thankfully, right? We never needed that again. But it did live a fairly luxurious life, and there's from the 50s to the 60s, all the cool people were on there, the Bob Hopes and everybody, and hobnobbing and everything you'd expect for that era of like luxury ocean travel. Long term, of course, we know what happened. Airplanes became cheaper, and it's a hell of a lot faster, and it might not be as exciting as an ocean voyage in a ship, but if you need to be there within the next couple of days, it pays for itself. So the whole idea of these luxurious transatlantic cruisers sort of went away, and now the United States just sits there. It's been sitting in Philadelphia, and it's just rusting away, and it's a real shame. There's been some talk of trying to turn it into something. There's a lot of sad parts of the story, but I think one of the worst parts is that at one point it was going to be turned into like apartments, which would be kind of cool. Like, they'd be like timeshare things or something. To try to pay for that conversion, they basically sold off the entire inside of the ship. Like everything was sold off. So if you look at pictures of the United States now, inside, if you would never know it's a ship. It looks like it's a warehouse because there's just, even the walls are gone. Everything's gone. It's just a hollow ship, just decks and decks of nothing. To try to return it to anything is an incredible undertaking. You got to look at, Maya's included a couple of videos, people walking through. Like, you can't imagine how empty this is. It literally is like a hollow shell of a ship where, like, they're looking at the ground and they can say, okay, well, this is the outline of where a bedroom would have been. You could still see, like, an inch tall base of the floor. Like, that's how little is in there that they have to kind of, like, imagine what the rooms look like. So that makes it very difficult to turn it into anything. Like there are no rooms in there that you can like rehab and turn it into a hotel. There's nothing. And all the commercial ideas have kind of fallen through. It's one of those sad stories that has repeated itself over and over again with these ships. I've always thought it was funny that, the Titanic, and its sister ships, obviously the Titanic very famously sank, and then the Britannic too. But like the Olympic, the surviving ship just got cut up, which I always thought was crazy. If there's ever like a famous ship to keep, and you'd think it'd be the Titanic's sister, but even then, at some point, it's a bunch of steel and it's a lot to maintain, and as much as we want to hold on to it for future generations, it just becomes impractical. So yeah, it's an unfortunate end for a lot of ships, and it's potentially going to happen again for this one.
I didn't even know about the Titanic sister ships. I'm gonna have to Google that.
It's a terrible story.
Give me a sec.
Honestly.
I'm gonna have to look that up.
Yeah, I mean, not to get too far off thing, but like, they made 3 ships of the class: the Olympic, Titanic, Britannic. We all know what happened to the Titanic. Britannic was sunk during World War I when it hit a mine, and then the Olympic, the surviving sister, served until the 30s, and then they were like, well, I guess we'll just cut it up. And it's like there is probably no more notable ship that ever existed than the only surviving, of its class. And if that didn't make it, right, if that wasn't turned into a museum, what kind of chance do these other ships have?
Right.
To think about it now, it's mind-boggling. I mean, I guess in the 30s, when they cut it up, it wasn't as big a deal. I suppose the Titanic has taken on a certain mythology to modern eyes that maybe didn't exist in the 30s. In the 30s, it probably was just like, man, that sucked. Like it was not this romantic story. It was just like, well, that was a terrible thing that happened, and nobody was.
Boat sunk, horrible tragedy. I'm not getting on that boat's sister boat.
Exactly. So, but to think of it now from our time period and be like, wow, they had one of them and just decided to cut it up is so hard to wrap your mind around. Personally, I always thought it was crazy.
Iron rusts in salt water, man.
Yeah.
What am I gonna say?
They're a little tricky to hold on to for 100+ years.
That wraps it up for this week's Hackaday podcast. Thanks tons for listening. If you want to follow the links or leave a comment, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, send us a line, tips@hackaday.com. And until next week,
keep on hacking. I almost want to say keep on degaussing, but I was going to talk about nonsense. So feel free.
What are you beeping about, sir?
I'm sorry. Did you hear I apologize. I didn't know you could hear that. I thought I was farther away from the microphone. I apologize.
Slight interruption. Good. Oh, that's wild. I didn't even know. Learned something on Hackaday. Oh, yeah. I should have stopped it before.
In a shocking turn of events.